Hi everyone, so this is Monday, December 6th lesson on volume of pyramids. So I'll just put the date over here. We are talking about pyramids and spheres today, and then I'll explain a little bit more about what happened in class. So volume of a pyramid is the formula volume equals 1/3 area of the base times height. Remember that capital B from the last lesson is area of the base. We're going to draw two pyramids and calculate their volume. So I'm going to draw a rectangular pyramid first. So I'm just going to draw kind of like a slanted looking rectangle to get me that three-dimensional. I have two solid lines, the front and the right side, and then the back and the left side are dotted. Pyramids always come to a point, so I'm then going to draw those from that point down. Okay, we're going to label the front edge 8 centimeters, the right edge 6 centimeters, and as a reminder, no edges are going to be the height. The height is always from the apex straight down to the middle, and that value is going to be 10 centimeters. So with this, it's going to simply be volume equals 1/3, whatever the area of the base is, times the height of the pyramid. The height of the pyramid in this case is 10. The base is this rectangle, and the area of that base would be 8 times 6. So that's what I'm going to put in there because rectangles have a base times height as the area formula. So that's how we get this. We're then going to switch to the calculator to type that in. I just want to quickly show you when you have a calculator, you're going to do 1. If you do control divide, it's going to get you that fraction. So 1/3, and then it's going to be simply that 6 times 8 times 10 that we have. Hit enter, and it's 160. So we have the volume is equal to 160 centimeters cubed, because volume is always in cubic units. The next one's a little bit more challenging. It's a triangular pyramid. So we're going to start by drawing a solid hypotenuse of a right triangle. I'm then going to do dashed lines for my two legs, and I'm going to draw that right angle symbol right there. This is going to be 10 centimeters. The left side is going to be 5 centimeters, and the right side is going to be 7 centimeters. That is just my base. Pyramids come to an apex, so I'm going to draw my lines down to each edge, and then a dotted line to that back corner. And I have my triangular pyramid. The height of this triangular pyramid, again, is going to go straight down to the middle of the base, and that value is going to be 11 centimeters for this circumstance. My formula is volume equals 1/3 area of the base times height. So I always suggest leaving that part blank, writing your height. So the height of the pyramid itself is 11, and then we can focus on that capital B, which is the area of the base. This shape is a triangle. It's a right triangle specifically. A triangle's formula for area is 1/2 base times height. So the first thing I need to remind you of is that it's 1/2. The second thing I need to remind you of, to get the base and the height, I'm going to actually draw this triangle separate right now. So if I'm looking at this triangle, there's my right angle, 10 is across from my right angle, and then 5 and 7, depending on which way you're observing it, are the other two. 5 and 7 are the base and height, because remember, base and height must always be perpendicular to one another. So the 10 in this case is just extra information. It's another length of an edge, but it's not part of our calculation. So I type that all into my calculator just like we did before. And when I do that, I get a fraction, and that's the part that I want to show you with the calculator of how to make that a decimal if you prefer it that way. So 1/3 times 1/2 times 5 times, oops, I did not mean to do that. Okay, I can show you here. So if you scroll up on your calculator, it will highlight, and then it will always just paste stuff down. So I accidentally hit enter when I didn't want to. So I just used that there, but I'm going to show you that in one more spot in just one moment. So I have 5 times 7, and then times 11. I hit enter, I get this fraction. Now I'm fine with you saying that fraction as an answer, but if the question asks for it rounded, you're going to need to scroll up to highlight it, hit enter, and then if you click the over arrow on your keypad there, it's going to go to the numerator. Just put a decimal point there. You can do this in the numerator or denominator, hit enter, and it's going to transform that fraction from its fractional form to its approximated decimal form. So when we do that, I'm going to go ahead and round it to the nearest hundredth just for the sake of the lesson, centimeters cubed. So that's volume of pyramids. Obviously with some practice, that's going to get you where you need to go. For volume of spheres, I have V equals 4/3 pi r cubed. That is our formula. To draw a sphere, it's going to be a circle. You're then going to make a curve in the middle, a backwards curve that's dotted towards the back, and you have your sphere looking thing. And I'm going to label our radius as 4 inches. So for a sphere, it's really straightforward. 4/3 pi, your radius, which is 4, cubed. And then we type that into the calculator and approximate it. When you type this into the calculator, again, I want to show you how it works. So if I do 4 control divide, it gives me my fraction, third. Click over to get out of the fraction. The pi button is located in the bottom left. Hit enter to select it. Parentheses, 4, close your parentheses. Now to get your exponent of a 3, you're going to need to click this arrow button next to the 4, and that's going to give you the availability to type an exponent in. Hit enter, and there you go. So 268.083 inches cubed. And it should make sense that you get a decimal for that. You are using pi after all. The next example is going to be a hemisphere, which is half of a sphere. So I'm going to draw half a circle, a curve to the front, a dotted curve to the back, and this time I'm going to give you a diameter of 10 meters. So this is a giant, like fish tank or something. So again, I'm going to start with volume equals 4/3 pi r cubed, but we're going to divide that by 2 in the end because I want half of the sphere. If you understand that 2/3 is half of 4/3, feel free to use that as your formula for a hemisphere, but I'm going to go through this by simply calculating the volume of the sphere and then dividing that by 2. Another quick tip, I don't want to type that all in again, so if I click up, and hit enter, it copies it, and then I can just scroll in, delete the 4, put a 5 in. So there I have that, so 523.599. And again, I need to divide that by 2 because it is a hemisphere. And another shortcut with that is in the calculator, whatever answer you have, if you want to divide it, you just click divide. Whatever you want to do to it, if you just click it, it will automatically copy whatever that answer was. That's what ANS stands for. So divide by 2, hit enter, and there is our final answer of 261.799 meters cubed. So after that in class, I handed out a packet. That packet has a calendar of everything that you need for the rest of this period, of this unit, excuse me. So when you get that packet, you will see a calendar, and that calendar has everything you need 5 days a week until we get to break. With the exception of the 8th and the 9th, in that packet, they need to be swapped. After this video, I'm going to post just the practice for this lesson and the homework that's due tomorrow for just this lesson. If you have any questions, feel free to send me a chat or an email. I am here. I hope you have a fantastic day, and I will see you later.